Hello, welcome back. We continue to our lesson. There's a 6.3 image formation by the lenses. Okay, let's see the first one. We need to introduce about the type of the lenses. Okay, let's see what means of the lenses. Okay, lens is a one piece of the transparent material such as a glass, perspex, or you say plastic. So that means the light can be passed through. So we call it as a lenses. Then which has a two surface. So at least one of the surface must be curved shape. So that one is a lenses. So from here we introduce two types. The first type we call it as a convex lens. The convex lens you can find it the center become thicker. So another one we call it concave lens. The concave lens the center is a thinner part. So this one is a two type of the lenses that we need to learn for this topic. Okay, concave lens, another name we call it as a converging lens. Converging means focusing. So later the light when they pass through the convex lens, they will convert all the light to the focus point. So this one we call it converging lens. Diverging means they will divert, that means they will spread out. So when the light just pass through the concave lens, all the light they will divert, that means they will make the light, that means they spread to wider area from the focal point. So you must remember, one is focus, another one is divert. So this one is a different shape for the concave and also convex. So this was a diagram for the lenses. Okay, now we go to the recommend about the convex lens first. We see what is the characteristic when the light just pass through. Okay, first one, a parallel light. So this one is a parallel light. Okay, one more thing to tell you. Parallel light means the light ray is from the far distant object. Maybe the object is very far. So that means we cannot focus the object. So we call it as a parallel light ray. Okay, they pass through the convex lens. They will converge at the focal point. So they will converging to the focal point. Therefore, convex lens are called it as a converging lens. So that's why just now I told you why they call converging, because after pass through the lenses, they will all focal to the focus point. So this one we call it focal point, F-O-C-A-L. Okay, can you see the small f? Small f actually is a distance. So the distance between the O to F. So this one small f, we call it as a focal length. Okay, now we explain. Focal point of the convex lens is real. Because refracted light ray, they will convert at this point. So this point, there's a real point that maybe we can capture on the screen. As such a focal length, there's a small f, as be the positive focal length. Because you can focus the image. So that means this one small f, we take it as a positive point. Okay, positive length. So that's why later we can see the image at here. Okay, now we see the example when the light pass through the convex lens. So this one is a ray box. So the light ray bearer pass through the convex lens. This one is a result. So can you see the three light after that they will go to one point. So this one point sure is a focal point. So this one is also another example. One part is a curve. So when the light just go, they will pass the refraction. So from this one situation we call it as a phenomena or refraction of the light. So after that they will focus, okay, focus to the focal point. So we can say it as a converging to the focal point. Okay, now we go to introduce every part the name. Okay, first one there's a parallel light. Okay, center part, that means they join the O to the F. This one we call it principal axis. So after the light they refracted to the lens, they will go through the focal point. So the distance between the focal point to the center, we call it as a focal length. So now they got one of the question. What happened to the parallel light ray after passing through the convex lens? So just refer the diagram. After passing the convex lens, they will go refracted, or you say the converging to the focal point. Okay, so from here the parallel light ray they will convert to focal point. Okay, after introduce the convex, now we're going to see the concave. Concave we also start by using parallel light passing through the concave lens. appear to be diverging. Just now it's converging to the F. Now it's a diverging from a F. So now the F is a negative F because the F is behind. So this one we call it focal point also, but there's a negative focal point. So now the light ray is diverging from the focal point. So you find it when the line they go to F, they're using dotted line. So this one is a negative part. So after that, they make the line become longer. So when the line make it become longer, you find it there's a diverging. So this area, you can find it the area wider. So when it just refracted come out, the light ray is a wider area. If compared to the convex just now, they just go to focal point, the area should be less. After that, there's a focus. For the divert, maybe they go to bigger area, but the image they become blur. So this one is the differences. So from here they say therefore concave lens as known as a diverging lens. So where is the focal length? Focal length just behind. So this one focal length sure is a negative value because they follow the focal point. They go to the behind. So we take it this one is a virtual part. Okay, let's see how to explain. Okay, focal point of the concave lens is virtual. Okay, because the refracted light ray appear to divert from this point. So they divert from the focal point. As such, focal length, there's a negative. So from here, we know for the concave, all the bigger f and smaller f, there is a negative answer. Okay, now we're going to see example for the light ray passing through the concave lens. Okay, 3 light, when they just go through, you find it, they will spread out. Okay, they spread to wider area. So this one is a differences for the concave and convex. So concave, you find it the wider area, but the convex, they focus to one point. So this one, another example for the concave. Okay, again, we go to introduce the structure part. First one, parallel light. Then after that, we got focal point. Now the focal point is behind. Okay, we also got principal axis. So when the parallel light just hit concave lens, they will refracted. They will refracted to the F. This one F is a behind F. After that, they will divert. Okay, from the F. Okay, convex is they will straightforward focal to the F. This one they will divert from the F. Okay, so the question is, what happened to the parallel light ray after passing through the concave lens? So from here your answer is, the parallel light ray now is a divert as they come from a point F in front of the lens. So they take this one is in front, behind is here. So when you find it they divert, they must go to the in front F first. After that they will divert to the wider area. Okay, now this one is a comparison for the convex and also concave. Okay, let's see the first one. Focal point. What means of the focal point? Okay, a point where the all parallel light ray, they are convert after refraction. So focal point don't care you are convex or concave. When the parallel light ray just go through, they must go to find F. Okay, so they want the F, we call it as a focal point. Okay, the next one is a focal length. Focal length is a distance. There's a distance between the optical center. Optical center means the O to the focal point. So that we call it there's a focal length. So you can see the focal length. Okay, next one is a object distance. So where the object you put there, so we need to count about the object distance. They must count from the distance between the optical center with the object. So if this one is the optical center, my object is put here. So that means we need to count object until the O. So this one we call object distance. So the symbol for object distance, we use small u. Okay, remember this one not initial velocity. This one is a light. Light, they're also using the same symbol, but the name is a different. Okay, then the last one is an image distance. Later, you got object. After the light pass through, they will produce the image. So this one image, we also need to count the distance. Okay, example, now your object is focused to the F. So that means your image is here. How to count the image distance? We also need to count start from the O. Okay, from the O until go to the image. So we call it as a image distance. Remember, every time we count the distance, we must start from the O. Okay, O is a middle part. So from here, they say image distance is a distance between the optical center with the image. So this one is an example how to create the experiment to file the image formed by the object. So first one is we must have the source. So the source you're using the candlelight. Okay, this one the lenses you must put at the center. Then after that the screen must the last one another side. So that means you can adjust your object distance. After adjust object distance already, so you need to adjust the screen. Okay, until you can get the sharp image, then you stop. Then we measure the distance from the lens until to screen. That one is a image distance. So this one is a one of the example. Okay, let's see the demo. So you can find it the light. Okay, so that means they adjust the screen until you get the image. So from here you can see they cannot capture all the light ray. So they need to adjust the screen. So until here you can see when the screen just closer, you can find it all the light that we capture on the screen. So this one we call it as a sharp image. Then we go to stop, we measure the distance. Okay, if you go further means the light already spread out. The screen totally cannot capture. So that one not a best way we go to measure the image. Okay, now this one is one of the example the student do the activity or you say the experiment. They want to file out the image. So the lenses is here. Then maybe the image is maybe the window. Okay, sorry, it's an object. Object is a window. Then after that they need to adjust the screen until you get the sharp image of the window. So they're using convex lens. So this one is a sharp image on the screen. So they say they adjust the screen position closer or you further. Okay, from the lens until the sharp image is formed on the screen. Okay, after you know there's a sharp image, then you stop already. Then you need to measure the distance between the convex lens and also the screen. So this one we call image distance. So this is one of the example how to measure the image distance. Okay, then the object distance normally we adjust. There's a manipulate variable. So from here we see the demo for the experiment. So from here you see they start with the 50, then they go to adjust the screen until you get the sharp image. So from here they get it, there's a 46. Okay, the first round they get it, there's a 46. Okay, now the second round, they go to adjust again, your U become 49. Okay, now they go to adjust the screen again until get a sharp image, then they stop. So from here they start to measure. From the lens go to the screen, there's a V. So from here they measure there's a 45. So we still continue. We continue number 3, they adjust the screen so until they get the sharp image. So from here, okay, we set number 3. Okay, they keep moving the screen. So until the U, they make it become 51. So then they get the sharp image when they adjust the screen, there's a 44 cm. So this one is a process. From this one diagram, they go to adjust the screen also. When you adjust the screen, mean you adjust the object distance. Then after that, after you fix the object distance, then you stop already. Then you let the screen to adjust. So they adjust the screen until they get the sharp image. So the image now is inverted. Okay, so this one is a sharp image, then they stop already. So they find it, they need to measure what is the image distance. So the image distance is a 44 cm. Okay, now we need to introduce the ray diagram. So that means just now we find it, we got image, is it? So we need to know how to draw. Okay, draw the ray. After that, we capture, then the ray that will overlap to each other. After they overlap to each other, that means they got the one of the point. So that point, there's an image. So from here, I need to teach you how to draw the ray diagram. So actually, every lenses, we also got 3 ray we need to learn. Okay, let me try the first ray. Okay, first ray, okay, this one I introduce first. This one is a convex, this one is a concave. This one is an object. So O is the center of the optical. Then F is a focal point. So we got in front, we got behind. So from here, normally for the convex, we are using the in front one. Okay, behind we're talking, this one is a behind. Okay, behind is a positive one, so the in front is a negative. For the concave, we were using the in front one. This one is a negative. Okay, we see how to draw the first ray. Okay, first ray, you must start with parallel. Okay, we parallel from the head of the object, go to the center. Okay, this one we call the vertical center line. You don't draw until here, they'll stop. We never count about the curve. We take the center vertical line. Okay, after that, remember parallel must go to find F, is it? So after parallel, then we go to F. So this one we call first ray. So later, we no need to repeat already. When I just say first ray, then you understood. Okay, let's see the concave first ray, how to draw. Okay, still parallel. Okay, also same. But this one, they will diverging from the F. So we see, okay, they will diverging from the F. So they're using the in front F. That one is a negative length. Okay, so this one is a first ray. Let's see the explanation. Okay, the ray which is a parallel to the principal axis, there's a refracted and passes through the focal point. They pass focal point. Let's see the concave. Ray with the parallel also to the principal refracted and appear to come from. So the different word is come from. Just now is passing through. So they will come from the focal point. So this one is the differences. Okay, for the convex and concave first ray. Okay, now we continue to second ray. So this one is the second ray. Okay, the object still the same. Okay, we try to see the convex second ray, how to draw. Second ray, actually, there's an opposite with the first ray. Just now, the first ray is parallel, then go to F, is it? So the second ray, they will go to F first. Okay, we check. Okay, we go to F first. Okay, we go the nearest F, not the further F. After go F, they will parallel. So that means the step opposite with the first ray. Okay, let's see the concave. Concave also go to F first. Okay, continue go to F. So remember, then go to F using dotted line. Okay, after that, from the head of the arrow, then we go parallel. So they almost same like the second one for the convex, but this one citation, you remember, they're using the dotted line, they go to the F. Normally the F for the concave and convex, they will opposite. If the convex using the in front F, the concave using the behind one. So remember the step. This one go F first, after that parallel. Okay, ray will pass through the focal point. F is refracted parallel to the principal axis. This one for the concave, ray travel towards the focal point, F, is refracted parallel to the principal axis. Just almost the same, because this one is a pass through the focal point. This one is travel towards the focal point. Okay, now we go to third ray. Third ray is the most easier one because they just got one line. From the object, straightforward, go to center, then go straight. Okay, for the concave, also the same. They go straight from the object, go to the optical center, then go down. Now the explanation should be the same. Ray will pass through the optical center, travel in a straight line through the optical center without being refracted. So that means they just got one line. They don't have any refracted to other line. Maybe they got refraction, but refraction in the same line. So this one we call third ray. Okay, so later we need to combine three rays together to draw the image. Okay, this one is a experiment result from the ray diagram. Okay, you can see the first one, they parallel. After that, go to find F. So this one should be the first ray. Okay, let's see the second ray. The light ray, they go to the F. After that, hit to the surface of the convex. Then they will refracted parallel. Then the third ray, just one straight line. They pass the center of the lens, then also come up. So this one is a first, second, and third ray from the convex lens. Okay, now we go and check the concave. Okay, concave also the result. You see the first one, parallel with principal axis will divert and come from the focal point in the front of the lens. So you can see the first one, the parallel. Okay, can you see the small light? They come back. This one is go to the F. Then after that, divert. Okay, the second one, we very hard to get it. So I show you the third one. The third one is straightforward, one straight line. The line pass through the optical center will go straight without refracted. So this one is a third ray. So this one is one of the experiment. They want to determine the position and also characteristic of the image formed by the convex and also concave for the different distance for the object. So that means this one experiment, they just adjust the object distance. After that, they want to find out what is the image distance. So from here, we know the manipulate variable sure is the object distance. So you see the ray box. After that, we got lens Z. Then we go to the screen. So from the ray box to the lens, this one we call it as a object distance. Then from the lens go to the screen, that one we call image distance. Okay, let's see the procedure how this one experiment to be function. First one, we need to adjust because they say manipulate variable is the object distance. So you need to mention your object distance is how many cm. Okay, after that, remember procedure 2. There's a adjust the screen. This word is very important. If you not adjust, that means you cannot get a sharp image. So from here, they say adjust the screen in order to form the sharp image on it. After that, you observe the characteristic of the image form. Then you measure the length lah. So we measure and record the image distance V. Okay, then number 5, we need to repeat it. So first one you set 40. Now you repeated the procedure 2, 3, and also 4 for the different object distance. So this one is the repeated. So you need to repeat at least 4 times for the whole complete report. Okay, so this one is some example for the student to do the experiment. So this one is a object. Okay, after that, this one is a lens. So this one is an image. So they find it, they get the sharp image, then they stop. After that, they need to measure. So this one also same. Okay, we see the real one. So from here, this one is an experiment. They want to show about image formed by the screen, but the student will adjust the object because they never adjust the screen. Either one. So from here, they want to demo. So they will keep adjust the object. You can see the image actually there's a inverted, then like this, like the blur. So they need to adjust until there's a sharp. So from here become sharp a little bit. Okay, like this, they find it become blur already. So from here, they need to adjust again until they get the sharp. Okay, blur. Then we continue. Okay, this one is almost sharp already, the frame. Okay, so if sharp already, that means you can stop. Then you can use the ruler to measure the distance. Okay, so this one is one of the experiment. They want to find out what's the object distance and also image distance when they're using the lenses different of the focal length. Okay, so this one is one of the experiment, also including for your syllabus for the KSSM, the physics. So from here, I think we just stop for the experiment. So the next lesson, I will show about the ray diagram, how to draw it. So hopefully you will continue to follow my lessons. So thank you for your watching.